And if you see them, please mention that. Maybe, G, you can mention it to Ka. Okay.
Yeah, I can check with Ka about whether she can join us.
Okay, that would be wonderful. Thank you so much. Good morning, Drew. Okay, good morning. This is the interim for IDR for 226. We have some status reports, but a lot of what we have is drafts. So, new drafts. So, just in case some of you are new, please read the note well. The ITF policies on topics such as patents or code of conduct is listed in the note well. So, just as a reminder, by participating in the ITF, you agree to follow the ITF process and policies. If you're aware of any ITF contribution covered by patents or applications that you own or controlled by your sponsor, disclose that fact or don't participate in the discussion. As a participant, you acknowledge that any written audio, video, and photographic records may be made public, and personal information you provide to the ITF will be handled in accordance to privacy. So please read this. It's the way we work together, and it keeps us working along smoothly most of the time. This is the agenda for today. We're going to bash the slides, and I have some details on draft status. Then we'll go through car CT status for me. DJ will provide an update, and Kaliraj and Nats will do an update on the three CT drafts. Good morning, Kaliraj. How are you doing this morning?
Hi, sir. Good morning. I'm doing good.
Thank you. I'm glad to have you here. By the way, the car and CT editors, DJ and Swadesh and Kaliraj, and the car editors, DJ and Swadesh, and the CT editors, Kaliraj and Nats, have been very active in the last week, and I appreciate last last several months, year, 2 years. I appreciate all their cheerful aid. Then we'll go through 3 or 4 new drafts or recycle or drafts which are discussing. So I will go through those in order. Uh, Please let me know if you have any question when you are next in the presentation. Please go ahead. Please note that the generic metric for AIG attribute is still being held over in adoption call. The chairs thought it would be really good to have Srihari present details on um, what's changed and issues they raised within the mail list. Okay, off to the calls for comments. We have 2 comments which Ketan has been very patient working through everything that went from a working group last call of draft ITF-IDR segment routing TE policy. It got split into 2 drafts per the AD review that sent it back to the working group. And then Ketan has been working with me to try to push these back to the ISG. I do need in this second working group last call just more support for consensus. So if you've supported in the past, please just say support. Um, the the ISG process works a little better if I bring something back to a second working group last call that I really get some support. Ketan has done a great job of reworking all the text. The thing that's important to know in this draft is that TE policy draft and that has now been reformatted in the BGP SR policy SAFI, uses a method like BGP-LS for validating the semantic syntax. I break that into the format and the links within the text. I call that the format syntax, just for this meeting, and the content of it is the semantic syntax or the content syntax. That is being validated in the SR policy SAFI by the SRPM. You should know that this is another focus. Please review and chat about that. The CAR and CT working group last call. I know this is again a second group working group last call, but please, I need because of the number of comments on the first working group last call, I need people to say, yep, the second version of the text works for both the CAR draft and the CT draft. You may indicate your approval of the CT technology by by draft, since the CT work has been split out. I'll go through that. The draft send hold timer will be coming back to us. It has gotten an IN allocation, and I believe the authors are making sure the implementations fit that. Other status. We need working group, we need 2 implementations for the following draft: the BGP model, the entropy label, and the 2 IFIT draft. If you have it, please let us know. We're waiting for a 3rd implementation on SD-WAN because we thought it might come in quickly, but it's been a while, so please let us know if you know of another implementation of SD-WAN. We are working on revisions of IDR-wide communities in RPD that went to the ISG and come back. We're also working on flow spec revisions. So if you have interest in any of that, please talk to the chairs. And we adopted draft G IDR MBGP extensions for map 6 and draft Kaliraj IDR multi-next top attribute. The draft Kaliraj IDR multi-next top attribute is not been uploaded yet, but we're waiting from comments from CARE. The adoption process, I mentioned that draft Sengli IDR BGP generic metric AIG is in process, and we have the following upcoming adoptions. We will start to remove drafts without implementations older than 10 years. If your draft fits this category, please notify the chairs if it's still actively in process or if it's been implemented and you really want to continue with standardization. Let's see how I'm doing. I'm running a bit late. Okay. I'm now transitioning into the second item, which is the CAR and CT. We're in the call for comments on the second working group last call. We have the editors, and by the way, Swadesh has sent in his IPR statement. So this IPR and missing IPR is a couple hours old. Thanks to all the folks sending in IPR. We will update the slides, and I will keep a running tab of IPR statements. The GitHub details has the issues for the resolution of all issues from the first working group adoption, the first working group call, and the Shepherd's report. Plus, it has will have the second working group last call issues and the Shepherd support. You can get you can read the link for GitHub, or if you have any problems accessing it or want to get comment access, please contact me. The current Shepherd report I sent out for CAR, a partial one, and I've broken the Shepherd reports down into categories of editorial. Editorials regarding procedures, which I must have addressed, editorials regarding IANA, which we addressed, editorials on normative, and editorials on appendices. I will ask these to be edited. Now, I've tried to send it out as a file, but it looks like in my mail, the new ITF processing broke the file up into pieces. If you want the file directory, please let me know. I'll also try to post it on the wiki. Okay, same is true for the second working group last call for CT. There are 3 drafts. The IDR chairs felt it was more useful to break CT into 3 drafts: the base CT draft, the CT used for SRV6, and a particular discussion on some advice for forwarding route reflectors that was included in the draft. You may support 1, 2, or 3 of the drafts. Again, my IPR statements are up to date. Rishma has given a comment. And again, the issues will be listed by type. Okay, that's all administrivia. I'll try to quickly finish my part. What's the schedule? Well, I hope to get the most of the working group last calls report and the Shepherd's report done by tomorrow. I expect that the forwarding RR may linger on till Wednesday or Thursday based on the number of comments. And I want to thank Robert and Igor and Kaliraj for their active discussion over the weekend. The chairs will determine the working group consensus on this Friday, and then I hope that the editors will and authors will release a final version by the 4th, so I can request publication. This has gone on long enough. Any other questions on the status? Okay, if not, I have taken long enough. I'm going to grab another slide share. We're going to start with DJ. Just a minute, DJ. I've got to give you the car update.
Thanks, Sue.
Oh.
Yeah. Can you go to the next slide, please?
Yep.
Yeah, a very quick update. As Sue already outlined, I mean, we've been working to address the working group last call comments from the first one. There are also additional early directorate and Shepherd's reviews. So those have been uploaded to the version 6. And then we worked with Sue to close most of the working group last call comments. Next slide, please. And yeah, so there's a few more updates, mostly editorial, addressing the Shepherd's review comments. So that's what we'll be working on updating in the next week.
And I want to underline that these are editorial comments in my Shepherd's review.
Sure, so thank you. Yeah, and so we just thank all the working group members who've been supporting the CAR draft progression over the couple of years. So please continue your support during the second working group last call. Thank you. That's it, Sue.
Yep. Anyone have any questions for DJ? Kaliraj, are you first or is Nats first?
Yeah, I'll be starting out, Susan.
Okay. Wonderful, Nats. Love it. Do you mind if I run the slides for you?
Yes, please. So this would be the agenda for the three drafts of CT. The two drafts got split out of CT. The current status is for the CT-based draft and the CT SRV6 draft. And there will be a short discussion on the RR with next upself for BGP, LU, and CT. Next slide, please. So the current status for the base draft, the latest draft is version 26. It's in last call. It addresses the review comments from Keir and Jeff. Issues that are raised against the usage of RD and implicit nulls were discussed and resolved. Addresses all review comments from the directorate. And the only thing that's pending here is the editorial comments from Sue, and that we will be handling. For the SRV6 draft, the latest version can be tracked at O2, and there is more information on the interdomain endpoint behavior draft, which is for SRV6. That is the draft which CT leverages. So that draft is being requested for adoption by Ron Bonica and Spring Work Group, and Susan has been notified of that adoption request. And it also addresses the review comments from Susan and the issues raised against the usage of implicit null label in pure SRV6 deployments that was discussed and resolved. Next slide, please. So the next steps are to wait for re-review and closure from Keir and Jeff and the directorate. For the SRV6 draft, the most is to follow up with the Spring Work Group, Susan, for the adoption of the SRV6 interdomain set in endpoint behaviors.
Just to highlight that the chairs of the Spring Group have confirmed that they know it's on adoption, and they've been informed it's part of our working group last call, so we'd appreciate aid. So they're in line with you. Thank you.
Thank you. And please do continue supporting CT in the ongoing last call. Thanks for all the support and thanks for the reviews. And with that, I will hand it over to Kaliraj.
Thanks, Nats and Phil. So this portion of the presentation is to talk about the RR with next top self draft. So this was initially a section in the BGP draft, and it was rightly pointed out that this thing is not specific to BGP. It's a generic BGP thing. So let's pull it out. So in the last few weeks of edits, we pulled it out as a separate draft, and that has rightfully given it more focus and attention. And we have been having discussions in the IDR about it. So what is this draft all about? So it's about, RRs are usually BGP speakers which do next hop unchanged reflection. And the procedures in 44, the RR based draft is like it recommends next hop unchanged behavior. But there are deployments like option C, inter-AS, where we use BGP-LU with ABRs, which are acting as RRs with next hop self. And this is not specific to BGP, like we already discussed. And so this draft describes a scenario where there's a possibility of forwarding loop between redundant ABRs in a region, which are doing RR with next hop self. So it just describes the problem and different ways to avoid it. And one of those options was a configurable path selection tiebreaker, where we suggested that cluster list can be considered before the originator ID. Where the original RFC says cluster list will be considered after the originator ID. So there was a discussion and a little discomfort on this option. So that is what we have been discussing, whether it is okay to go ahead with this or not. And we have been having a good discussion with input from Robert and Igor. So we will just go over the problem in this session so that everybody is aware of what we're talking about and what options are there. so that we can, as a working group, we can decide on what options we can leave in the draft documented or not. Next slide, please. So this is a hastily pulled in diagram from the draft. So here we have a provider network with two AS domains, AS2, AS1 and AS2, and AS2 is split into two regions, and it's an option C inter-AS VPN deployment. And AS1, AS4 and AS3 are like the customer networks, the C networks. So the focus of the discussion is the two regions in AS2, where you have the ABR23, ABR24, which are doing the RR with next top cell functionality, and ASBR21, ASBR22 are the ASBRs. So the traffic direction is from left to right. That's from PE25 to PE11, and which means that the routes are coming from right to left, PE11 to PE25. So to reach PE11, ASBR21, ASBR22, they re-advertise the route with next stop self to the RR27. So here the assumption is both the regions have a lot of ABR nodes. So we are using route reflection in these regions as well. So we have RR27 reflecting routes between all the nodes in region 2, and RR26 using route reflection between all the nodes in region 1. So ASBR21 route goes to RR27 with next hop unchanged. It comes to ABR23 and ABR24. And ABR23, ABR24, they realize these routes that they are receiving from ASBR21 and ASBR22 with next hop self to RR26. And RR26 re-advertises these routes to P25 as well as the other ABR. And so here to be noted that add path is enabled on the RRs so that it avoids path hiding. So the RR26 will be giving the redundant paths that's coming from ABR23 to ABR24 and vice versa. So this causes the route list that we show below, that ABR at ABR23. And before that, so basically we have RSVP LSPs in the region 2, where we have ABR23 to ASBR21 and to ASBR22, ABR24 to ASBR21 and ASBR22 with certain metric assignments. And the metric assignments are shown in this path selection topology. So the metric assignment is such that the route from ABR24 wins at ABR23 because of router ID, and the route from the ASBR21 loses because of IGP cost. And similarly, at ABR24, it's possible that based on the metric, it's possible that the route from ABR23 wins, and the route from ASBR21 lost because of the IGP cost. So when this happens, and there is per prefix label allocation, ABR23 and ABR24 will allocate a label and advertise it to the RR26, which is pointing to each other. So that will be a traffic forwarding loop. So that's kind of the problem that we have here. And we have just talked about the different necessary conditions here. We can just, if you pass whatever we discussed now. So how do we avoid this? What are the options for this? So as we see here that the route 1 and route 2, though the cluster list is longer, we were choosing route 1 based on an arbitrary entity like the router ID. So that is why that option was proposed. But let's see the other options that are available to deal with this. Next slide, please. So I think this option was proposed by Robert, that if we use the same cluster ID on all ABRs, then this avoids the loop. And of course, IGP cost-based planning also is possible, but I have a little bit of hesitance because IGP cost can change during network churn, and it also makes planning complicated. So if we have something more stable, then that will be better, so that it gives a better safety net. So that is why I was thinking about the path selection change, but using the same cluster ID on the ABRs, that also looks good to me, because that is like safe enough and it is stable. And of course, using AIGP cost, it accumulates the IGP cost on each next hop self re-advertisement, So that's better than just relying on IGP cost, because IGP cost, it blindsides us from whatever happened before the next stop self, because we only look at the IGP cost to the first next stop. So AIGP cost is also better. It provides a tiebreaker. So that's I think it's a valid solution. And if we are using BGP-CT, then if it was a BGP network, then we don't provision the color tunnels between the ABRs. That's one way to make sure that the BGP-CT route from the other ABR remain unresolved. But if we do the cluster ID step, then this is also not required. And the path selection change, it's basically, we were suggesting a configurable path selection tiebreaker, where we can say if these ABRs are doing next stop self, then do the cluster list before originator ID step. And I don't know if there are any conditions where cluster ID, configuring the same cluster ID is not possible. I don't know if anybody is considering IBGP clause, like eBGP clause. If something with respect to, I mean, parallel to ACE path, if we need something in IBGP networks, and if cluster ID or cluster lists satisfies that requirement in all cases, maybe not. So that is where that discussion is going. And so though we have not got any concrete data or examples of where this path selection change may cause a problem, but we see that there is a fear of unknown, and we respect that, because it's impossible to predict everything. So based on the discussion so far, and because we have the same cluster ID on all ABRs approach, so currently our thought process is that we are considering removing the option of the path selection change from the draft, so that we have at least the configurable options, and this document provides us a guidance for anybody who faces this problem on network design. And this option, because we have discussed this and the pros and cons, and in future, if at all we need it for some other cases where the other options are not possible, then we can use this. Actually, I think there were two other options mentioned in the updated slide, and that's not come up here. So I'll just go over that, and you can see it later offline. So per next stop label, if we use per next stop label, that is another way to avoid the loop, but it's partial, because per next stop label will avoid the loop if in towards the RR26, but the routes.
We lost your audio, Kaliraj. I think we lost Kaliraj's audio.
Oh,
there
gosh.
you are.
Okay, yeah, I think it muted me automatically. Sorry. So I don't know where I was. I was saying that there were a few conditions,
Per next stop label, Kali.
sorry.
That's where we were discussing that option.
Okay, yeah. And the last option was like, don't use route reflection in the region one. So that's basically, I mean, if the assumption is that a lot of ABRs, then route reflection helps. So I think configuring same cluster ID on all ABRs is the recommended approach. So we'll be updating the draft using this.
Thank you, and thank you to Robert Nigar and those chatting. I'm going to go to the next slide, Kaliraj, and that's a thanks. Any other thing you'd like to mention, Kaliraj or Nats?
No, I think we are good.
Okay, we'll go
All good,
on
sir.
to the next presentation. Danitas, if you'll be ready, I'll be putting your slides up.
Yep, thank you.
Let me know if you can see the presentation.
Yep,
I will run the slides for you. Go ahead.
thank you. So, hello everyone. We had, in case you missed some threads on the mailing list, when posted the version 00 of the draft. And the problem we're trying to tackle here is to reduce the number of paths, or also the number of updates for environments where devices are running under low resources. And one of the trivial examples would be PEC relationships, where C devices can deal with a large amount of routes. However, wants to have a backup path or some multiple paths. Let's say P sends 100 paths for an arbitrary prefix, which obviously consumes memory and CPU. So if you receive, let's say, 100 full feeds, back of the envelope consumption is around 50 gigabytes of memory and lots of CPU cycles. So with this proposal, the receiver could signal the sender to send only an arbitrary number of paths instead of sending all the paths or whatever the sender has. And as a side note, some implementations already have a configuration to send only some number of best paths. Then why don't negotiate about the actual number of paths to send on the wire dynamically? Originally, at paths capability defines the flags per AFI-SAFI to signal the sender that the receiver does not want any additional path at all. In other words, disable incoming paths. But for redundancy, that might influence route flapping. So here, instead of disabling the backup paths to be received, we can signal the sender about the number of paths we want to receive. Next slide, please. At paths capability actually cannot be extended backward compatible way because it strictly requires capability value to be 4 bytes. And also the flags received with values other than specified in that RFC are invalid and capability is just ignored. So we propose another BGP capability that extends at path capability to allow specifying the number of paths the receiver wants / capable to receive from the peer. And if at path capability is not used between the neighbors, then this new capability must be ignored also. You might wonder why 2 bytes for path limit, but I've heard about various crazy scenarios with more than 255 next hops. So that might be proactive and avoid some another change. Next slide, please. What's changed from 0.0 is that IANA already assigned a number for this new BGP capability. And there is, as far as I know, one open source implementation. The code and the functionality can be inspected in FRR repository in GitHub. Also, FRR implementation works with BGP dynamic capability. So this new path limit can be adjusted on the fly without resetting the session. Next slide, please. So what we are looking at is getting more and addressing existing comments. If you missed the thread, you can check the version 01. Also, the next step is to work on more open source implementations. And we, of course, eventually would like to ask for the adoption. And I think that's it for this short presentation. Thank you.
Keaton, go ahead with your comments.
Hi, Ketan Talaulikar, Cisco. What happens if the peer sends more than the number which has been signaled?
You mean if?
So let's say peer A sends this capability with say number 8. Peer B sends 10 paths to it.
Yeah, normally it shouldn't, but that's how it works. I mean, negotiation.
So, but this is not necessarily a negotiation, right? Because peer A may support 8, peer B may support 10. So it's not really a negotiation. It's more of a capability signaling, unidirectional, right?
Yeah, but the idea is not to send more than I requested.
Okay. I mean, the reason that I raise it is because I think there have been discussions on the list, and I also see Robert saying that on the chat. Could you consider that this may be like a more like a informational or perhaps like good to honor kind of a thing, but not must honor? And this is because of the implications it has on the sender side.
Thank you, Robert. I just remembered that I missed to respond to your feedback in the mailing list. I'll do that today.
Addressing KTID and also Robert. So yes, if the client doesn't support this capability, obviously it's just going to ignore it anyway. So that means that any implementation that wants to use this has to be prepared to accept potentially more paths than it wants. And what it does is a local action obviously is up to the client, just like if it had gotten, say, 1,000 paths it didn't want anyway, it can apply, per destination limits, throw them away, any number of local mitigations. So this does not intend to address all of the issues. The second piece of it is that during some transient scenarios, like you're going from advertising one path to another path, there's potential for you to eventually have the stable number of paths that you're asking for, but maybe in a transitional fashion, depending on how the updates are queued, you might temporarily burst over this. So this is not envisioned as a hard cap. To address Robert's point, what he's basically talking about is the usual update group split problem. What I'm going to point out here is that really this is not much different than, say, like RT constrain. Implementations solve that problem by basically selectively not advertising things to peers as part of its internal advertisement mechanisms. So it's generally envisioned by the authors that an implementation that is capable of selectively suppressing prefixes may do the equivalent of saying, I want to send everybody 100 prefixes, but I effectively suppress sending everything but the ones that are the top N to a specific peer that has requested that. And by suppress, I don't mean throw the update away. I mean, in a stateful fashion, simply do not advertise it, or if it previously had advertised it, withdraw it.
Kaliraj, go ahead with your comments.
Yeah, so I was thinking it may not be the same as RTC because here, I mean, I agree with that group split. So RR is not in control now. Basically, if different PEs are sending different at path receive, then it could happen that you have a split of groups at the RR, and we need to maintain the different at path send advertisement state, which is kind of per peer or per subgroup, which is having the same receive. So it will have additional load on the RR, I feel.
Kayer, you're next.
Can you hear me?
Yes, I can. It's great to hear you.
Super. I agree. It's not same as RTC. RTC was only used for filtering purposes, and that's why you could optimize it. Here, you have to rearrange and update message, unless, of course, this is used for an informational purpose only. So you would have to naturally split the update groups. But there are other consequences from an error handling that seems to have not been taken into account from error handling standpoint. So those may need to be hardened up. And really, it'd be good to understand the motivation as to how is it that you run out of memory and therefore are asking to reduce number of paths. Is that the only use case? And in this world of 64 bits, this seems little more stretched. Uh, so understanding a use case would also be helpful. Thank you.
Any other discussion? Oh, Jeff, go ahead.
Yeah, responding to Kayer. The easy use case is places where ad paths all are used by some implementations, and you have some clients that selectively want to restrict that from the all case. In such cases, you could certainly have the clients restricted to a subset of all at configuration at the reflector, but permitting this to be signaled from the clients is the foreseen use case.
Yeah, I'll simply say this that the fixed number of implementation configured paths, which I think the author said that some implementation support would be suffice. Is there anything else that is there that requires you to signal it? Is the question behind question I was hoping to ask, but I can take it on the list.
It would be good for Donatus and Jeff and Alvaro to put a summary of what they think the concerns are on the list, and for KRU to respond to that. That would be helpful.
Sure.
Anything else? Okay, we will go on to Kevin Wang. Just a minute, Kevin, let me change. Nice new node. Nice new. How about that? Kevin, can you see your presentation?
Yes, I can. Thanks, Sue. Are you able to hear me well?
Yes, I can hear you well.
All right. Thanks, everyone. So this is a new draft published late last year. Jeff Haas and myself are the co-author of this draft. So it's called BGP Next Hop Node. Next slide, please. Yeah, so first about the background, like why we need this. As we know, traditional BGP routing signals the next hops of routes, right? That's the fundamental of routing. And but in certain scenarios, such as the cloud network in the data center, not global node balancing, we would like to know the next hops in addition to the next hop. So the diagram I put on the top left here is showing cloud network, 3 cloud network, how global node balancing works. So let's say in this topology, we have 4 leaf nodes, L1, L2, L3, L4, and then we have 3 spine nodes, S1, S2, S3. Let's take one example, and let's say leaf node L1 is sending traffic towards leaf node L4. So he has 3 next hop links he can take, A, B, C, right? So if he takes A, the traffic is going through S1 and then towards L4. If he takes B, traffic is going through S2 and then through Y4 towards L4. Similarly, like if he takes C, it's going to go through S3 and then Z4 towards L4. So what has been solved is like if any of the link of ABC is congested, so L1 would be able to detect it, and he could move the traffic, some of the traffic towards the other 2 links to mitigate the congestion. However, if X4 is congested, X4 is the link from S1 towards L4, because this is the only link for S1 to reach L4. So S1 itself cannot do anything to mitigate that congestion. He would have to rely on the previous help, like L1, to mitigate the congestion, like by offloading the traffic from link A towards B and C, go through the other 2 spines towards L4. So this is called the global node balancing. So in order to do this global node balancing, L1 has to know, like, if I take my next hop A, my next hop is going to be X4. Otherwise, when he knows X4 is congested, he won't know like to offload the traffic from A to B and C. So that is the motivation of proposing this new draft where we let S1 to signal its next node L4 towards L1. So what we are going to do is we will define a new capability TLV in the existing draft called BGP next hop dependent capability attribute, which is today like only the attribute enable capability is defined there. So we are going to define another TLV there to signal this. So with this capability, what we can build is a routing table like on the right hand side, where you see like to reach L2, like today's routing table would tell you like your next hop is ABC. And with this new capability, we will know in addition to ABC, we will know like, oh, sorry, that's, I'm not done with that slide yet. Okay, yeah, so you will know like if I take A, my next hop is going to be X2. And then if I take B, my next hop is going to be Y2. So on and so forth. So we build this kind of information, like we have the next hop to next hop mapping built for each route. Next slide, please. So here's a brief summary of the existing draft called BGP next hop dependent capability attribute. So it has address family, and then it has the next hop there, and then it defines any number of capability TLVs. So today, the only capability TLV defined is the entropy enable capability. So what we are proposing in the next slide is a new capability code. Yeah, next slide, please. Yeah, so here is what we defined for the next hop nodes, where the capability code is going to be assigned, and the length field is a multiple of 4. And the value field start with the next hop BGP ID, which is the advertising router's BGP ID, and plus a set of next hop BGP IDs, because a given route could have one or more next hops. So that's why when we advertise it, we advertise them as n number of next hops. So with this combination of BGP ID and the next hop BGP ID together, it defines the next hop links for the receiving router. All right, and next slide. So next steps, we are seeking for feedbacks and comments. Also, we are looking for additional collaborators. Thanks. I see there's a question from Linda.
Can you hear me?
Yes, I can hear you.
Okay, so I'm curious because we have 5G, the metadata service capability, which indicate this particular end node, their capability to supporting the incoming traffic. And I'm just curious here, the value you have is just the next hop. What else are you going to put in the capability value field?
Okay, so
Can you
Sue,
bring
would
that
you
page
mind?
up?
Yeah, so would you mind to go back to that slide 2 with the topology? Yeah, this one. So what is here for BGP is really just to discover the topology, like to reach a certain route, right? You know the next hop, and given the next hop, you know the next hops, right? So this is what is not covered in this draft is the underline, the link layer. There's going to be somehow going to be another draft or protocol specifying like how the actual congestion status or link quantity that will be exchanged at the link level, not at the BGP level. And that one doesn't have to know the topology of each route. That will just be like, in this example, like S1, he would be monitoring the congestion status of all of his local links, like A, X2, X3, X4, right? And then he would just send this link quantity he monitored towards his neighboring node. This is just one hop away signaling.
So what will be the value, the capability of indicating the congestion indicator or what?
Yes, it will. So
Like
the simplest one is that
numerical value?
is congestion, like what is the congestion status, right? You could talk about like I'm lightly congested or I'm severely congested. But that is not covered as part of this draft.
So the capability TLV value could be a number, a floating number or something, a percentage or something?
Are
That's my
you
question.
talking about the BGP, this draft, or you talk about the link level link quantity exchange?
Okay.
I mean, is your question about this draft or about the link quantity itself?
No, I'm talking about this particular draft. You're talking about
Okay.
capability TLV. I'm curious on the value of the capability TLV.
Oh,
So
the value. Sorry, yeah, Jeff, you can have the answer.
Yes. Sorry, Linda. The thing that may not have been clear from the beginning is this is effectively a topology discovery mechanism. So using the topology that's on the screen here, L1s in traditional fabrics, we simply, if you had paths from all of the different nodes and there's no congestion, you'd want to do equal cost across A, B, and C. The problem here is if you happen to have upstream congestion from the link that's attached to S1, you may want to bias how much traffic that you send so that it's not equal cost anymore to A, B, and C. You may want to actually adjust the weighting of that. To do that sort of operation, you need to know two things. Thing number one, what is basically the upstream's things that you're load balancing for? The choice in this draft is you're learning the next hops. And the second component that Kevin's giving is the link quality component, which is the piece that you're asking about. And the goal here is we're not trying to put the individual weighted ECMP values into the capability that's being carried, because that gets very noisy. The criticisms we've always had about trying to put link bandwidth in a very dynamic fashion to BGP is BGP doesn't deal with such dynamic things very, very fast. So instead, the choice here is here's the topology component that's necessary to figure out what the weighting is going to be distributed over, and the actual link quality is distributed on the side channel.
Okay. I'm still not clear the value. Like I know it's for topology discovery. Are you still running the IGP there? The IGP will be able to pass the information on the link
No,
congestion,
this
right?
this is the using BGP as underlay. There's no IGP in this network.
Okay.
Because as you know, in the data center, in the cloud network, hop by hop eBGP routing is the dominant routing protocol.
Okay.
I see Keel has another question. Keel?
Yeah, I have a quick question. Have you looked at newer technologies like BGP, SPF, and LSVR, where you only build flow networks using BGP, but yet have a ability to build graph underlay and then do some kind of a link bandwidth to figure out what's going on?
I'm sorry, your voice break out a little bit. Can you help to repeat the question?
I said, have you looked at BGP, SPF in LSVR working group, which helps you build an underlay graph in the class networks, which also uses BGP underlay over BGP overlay to get what you want with link bandwidth?
No, I have not looked at that. If you can you point me something like about it? I would understand
Well,
how. Are you saying that it is already helping you to know the next hops today?
well, you don't, it builds the entire graph underneath it. So it not only lets you know next hop, but it also lets you know next hops all the way, depending how deep you.
I'd like to trim the mic queue at this point as we've run over time. Please send out these questions. And again, I'm going to ask Kevin and Jeff to provide a summary of issues they think happened at this working group so we can continue to discuss it. Our next speaker is Nan. So Nan, if you will be prepared. Do I have the right presentation?
Yes, thank you. So,
Okay, I will run slides for you. Thank you.
thank you. Hello, everyone. The topic of my presentation is BGP flow spec for source address validation. This is the first time to give the presentation about the draft in our working group. Next, please. Sub-rules can be used to check the validity of source addresses of packets on routers. The router can check whether a source address coming from the wanted interface. Existing sub mechanisms can generate sub-rules on routers, but in some cases, the rules are not accurate. To facilitate sub management and improve sub accuracy, additional sub-rule dissemination tool is necessary. So we considered whether BGP flow spec can be used for sub-rule dissemination because it is a very useful tool for traffic filtering or controlling. Currently, it has supported source prefix matching by carrying source address component in LRI and various traffic filtering policies, but it doesn't support binding valid or invalid incoming interfaces to specific source prefixes. So this document, we define a new BGP extended community named sub-interface set extended community. If we want to disseminate a sub-rule to BGP router, we can put a sub interface set extended community in the BGP update message. And at the same time, we need to put a source prefix component in the BGP update message. If we want, we can also put filtering actions of existing BGP flow spec. We have some use cases. We can install the sub-roles remotely and flexibly from manual configuration or centralize the some mechanism. It can also use together with distributed mechanisms for improving accuracy. Next, please. BGP flow spec, we define a new extended community. The design is very similar to the existing draft titled the draft name is flow spec interface set. We have a couple of fields. Field 1 is type. We have two optional values. One is for transitive community, and the second is for non-transitive. The two values have been allocated by IANA. And second is subtype. It needs to be allocated by IANA. And the third is S number. It indicates the target AS where the sub-rule takes effect. And fourth is group identifier. It can be used to identify a set of interfaces on the target BGP router. And we have two flags. The first flag is to indicate whether the interface set carried in the message is valid for the source prefix or invalid for the source prefix. And the second flag is to indicate the rest of interfaces on the router are unknown for the source prefix. If the flag is 1, it means the rest of interfaces are unknown for the source prefix. I mean, we do not know whether the interfaces are valid or invalid for the source prefix. So the validation result will be unknown. Next, please. Here we have a use case. In the example, let's focus on the medium AS. We deploy our sub mechanism on router 1, and in this example, we suppose the customer AS on the left advertises BGP routes asymmetrically. So if we deploy URPF on router 1, router 1 will will accept packets with source address P1 if the packet is coming from the interface of ID1. But the packets with source address P2 will be blocked on router 1 if the packet is coming from ID1 because router 1 doesn't receive the BGP updates of P2 from customer AS directly. So if we use the BGP flow spec for sub rule dissemination, we can remotely configure source prefix P2 as valid at router 1's interface with the group identifier equaling ID1. And that's a simple example. So to generate the sub rule, we can use a manual configuration, or we can collect some information from BMP, IRR, or RPK data, and also it can come from some security analysis center. Okay, that's all. Any questions?
I have a few questions, if that's okay. I'm gonna back up to this extended community. This extended community is taking an action. that says the interface is valid, the interface is not valid. Do I understand what's happening here?
Yeah. In the packet, we may carry the set of interface. We use the group identifier to identify a set of interfaces on routers. The identifier should be configured on the router in some way. And here we have flag v. If flag v equaling 1, it means the the identified interface set is valid for the source prefix. The source prefix is carried in the NRI of the same BGP update message to get yeah. I mean, if the source prefix if the packets with this source prefix arriving at the router from the interfaces contained in the identified interface set, the packets will be considered valid.
So I think I understood what you said. This is not a flow spec filter. This is a flow spec action that sets the interface valid or not. Do I understand the intent of your draft?
Yeah, yes, it's not action. It's maybe because it's used to disseminate the sub rules. The sub rule is to match to check the validity of packets. So yes, it's not action here.
It's a filter.
Yeah,
Maybe
it's a filter. Maybe a filter.
Most filters are in the NLI and most actions are in the extended community. That's why I asked. Maybe we could address that on offline. I'm a little confused why, if it's a filter, you're putting it in an extended community instead of an NLI based on the V2 FlowSpec V1 and V2 format. I when I read this, I thought it was you're trying to do an action taken care of by the flag to say this is invalid. These interfaces are invalid for this prefix to come from, or these interfaces are valid. So we can take this offline so I can try to help you, or if anyone else has any comments on this.
Understand. Thank you.
Okay. Anyone else for comments on this draft?
Jeff?
Yes. So my comments overlap Sue's a little bit. I think FlowSpec is a very strange place for us to want to put the actual prefix distribution, which I don't think is what you're intending here. For the community specifically, what you're trying to do is construct the equivalence classes of interfaces that are going to be getting a specific source address filter applied to it. I think what you're going to find is that the space you're defining here is too small, for this to be useful in a domain-wide context. Even though there's a large number of bits available here, the number of equivalence classes will probably be much larger in very large networks that some of the SAFnet stuff is being pitched for. So I think this doesn't change the idea in terms of wanting to have a community as the filtering entity, but you're going to probably want a bigger number space for this.
Do you think?
Okay.
Do you think you're looking at a wide community, Jeff, or do you think you're looking at something else?
So wide communities just are a specific mechanism that fits in the community container. We're looking for something that is potentially just bigger than an extended community can encode in the standard 8-byte format. Using a different analogy, like the IPv6 specific extended communities, if you were to allocate one of those code points, right now they only have route target, route origin defined for them. If you're to allocate one of those, you have a much larger numbering space to be able to put this stuff into. So we already have existing formats that can carry something bigger. But I think the work that Nangang is working through with the SAVNet stuff is how do we actually construct these sets of group identifiers across the network in a way that allows us to deploy these either on a targeted fashion, because sometimes these will be distributed to routers individually, or potentially they'll be distributed via route reflection. I think we'll see a little bit of the discussion in the next presentation.
Okay. If there's any other comments for Nan, otherwise we'll go to the next presentation. Okay, let me go to the next presentation.
Okay. Hello. This presentation is about BGP subnet. Is BGP extension. We propose a BGP extension to help routers generate sub rules distributedly and automatically. Next, please. This is the second time to present the draft in our working group. We consider that there are already some mechanisms such as ACL-based filtering and URPF-like mechanisms. But in some cases, they have some inaccurate validation problems or high operational problems. So in this document, we consider that we propose to use extended BGP messages to advertise sub-specific information. Here, sub-specific information can be asymmetrically advertised rules and or prefix tagged as internal prefixes or target source prefixes with expected incoming directions. The figure shows our main idea of BGP subnet. Existing some mechanism usually rely on local routing information to generate sub rules. But now with BGP subnet, we can generate sub rules with both local routing information and sub-specific information. So the sub rule can be more accurate. And the BGP subnet can be used for both intra-domain and inter-domain scenarios. Next, please. During IETF-118, we received many valuable comments, and comment one is from David. He disagreed with security considerations in our previous draft. In our previous draft, the security consideration section only has one sentence, is to be determined state. So currently we have updated this section by discussing from two perspectives. One is communication security and the second is content security. And we will continuously refine this section. And the second is from Antoine. He is interested in the validation of prefixes carried in our extended BGP message. And it needs more clarification. So to respond to this comment, we have added more descriptions in the corresponding section. Briefly, source AS can advertise a set of source prefixes that must be validated by ROV at the validation AS. That is, the validation AS should check whether the source prefixes from source AS are valid or not. If the source prefixes are not valid by after the ROV check, the updates should not be used for generating subrules. And another method is to get the target source prefixes directly from the RPK objects. This is also a suggestion from Antoine during our talk offline. And the third comment is from KU. My first response is we will present this work in the subnet working group and bring the discussion results and feedback to the IDR working group. And second response is we have added a new section to discuss the convergence problems. Of course, I will have added some descriptions in this section, but is we will continuous refine this part because we are improving this solution design, and more details will be added into this section in the future. Next, please. The final slide, we made some updates on most of the sections of this draft. Some are to respond the comments during the last IETF meeting. Okay, that's all. Thank you.
Yeah, just a quick comment. Thank you for taking my comments in, and I will review once the section is ready. I will be more than happy to review it. Thank you.
Thank you.
Hello, Susan, can you hear me?
You're loud and clear.
All right, wonderful. Hello, folks. This is a presentation on the AIGP extensions to carry the generic metric types. Before we jump into the specific topic of discontinuity in AIGP, let me sort of set a context. AIGP, as we know, 7311 RFC states we can have accumulated IGP cost across AS domains carried through and will be used in our best path completion. And the way to do it is having it's an optional non-transitive attribute. So you have to get the attribute carried through until the ingress router for us to be able to make a decision on. Now, we proposed as part of this in the last IETF sessions about how do we carry the generic metric, and we have identified issues, and that's the issue that we want to talk about in this session. So the issue here is discontinuity in AIGP. So before we get to more details as part of this, today, as per 7311, we have different implementations or different interpretations of the RFC. Some vendors propagate the TLV and drop unrecognized. Some vendors carry other than IGP default metric in the AIGP TLV. And some propagate AIGP attribute only if the AIGP TLV is present. That means they will drop the entire attribute if the AIGP TLV is missing. And there may be a few more interpretations of this RFC. I just listing out what I've heard here. Next slide. All right, so from a discontinuity perspective, what am I talking about? You can see the graph at the right side. Let's say you've got all these routers and they represent individual domains, let us say, and they are propagating a route from R0 and it is propagated to R5 through both the north path as well as the south path. The interesting thing is the R4 router does not support AIGP. Let's say if this were the case, even though 7311 has been around for close to a decade, let us assume that there may be some router that does not support AIGP. And what does it mean for supporting generic metric? So given AIGP is a optional non-transitive, and then the discontinuity issue is addressed because it's shown up because some router does not propagate the attribute because it is non-transitive. Next slide, please. The base BGP RFC supports the partial bit, where any router can say that I'm not able to understand, but this is only applicable for optional and non-transitive, right? So whereas here, sorry, it is applicable for transitive attributes and optional and transitive, whereas AIGP attribute is non-transitive, so therefore the partial bit has to be set to zero always. So the only way to do this is the discontinuity workaround as per 7311 is if a router R4, for example, does not understand AIGP, then R5 gets two paths, one via the R2, R1, R0 path where the AIGP accumulation happens, and the other path does not get AIGP attribute at all. So the 7311 says prefer the path with AIGP accumulated path. So therefore, you tend to focus only on the not bound path. Okay, next slide. Now, if you introduce in such a 7311 mechanism, if you introduce generic metric, what happens? Again, if a router does not understand AIGP, then even the generic metric TLV, as per the right top picture, the generic metric TLV in the AIGP attribute also will not reach R5. So R5 gets to choose only the north path, the R2, R1, and R0 path, just like 7311. Now, on the other hand, let us say we assume all the routers do support AIGP attribute, so they do propagate the AIGP attribute, but for some reason R4 does not support the generic metric extensions in the TLV, in which case what happens is the AIGP attribute still gets propagated to R5, and R5 will have two paths. The northbound path, the R2, R1, R0 path has a fully accumulated AIGP value, whereas the southbound path has probably not accumulated, and therefore it may show up as a better cost. So somebody may want to prefer based on the cost value, so they will end up choosing the southbound path, even though it is incomplete. Right. So this opens up the problem that we can't just have the AIGP attribute carry the generic metric, and we also have the next slide. Next slide, please, Susan. So in the generic metric, as per the IGP's metric type definitions, we can introduce down the line more metric types. So a generic metric TLV carrying multiple metric types, and that can happen over time, will end up having this sort of a problem where a metric particular type gets carried through without knowing whether it was updated, accumulated properly, or normalized properly or not. Right. So this shows up the discontinuity in more glaring fashion in the network. Okay, next slide. Okay, so we have two options. In the last IETF session, I introduced the AIGP attribute option, where we are going to evolve AIGP attribute, where we're going to introduce a flag in the generic metric indicating it's discontinuous. And we also have other flags that I'm going to talk about in the next slide. And upon discussions, and this is where I want to bring in what the discussions happened on the alias, that there were proposals on, can we do next hop capability attribute? Can we use that because that defines the scoping of an attribute, and can we leverage that? So I'm going to share here the thoughts, what the authors have come up with, and then look for input from the working group. Next slide. Okay, so AIGP attribute to carry the generic metric TLV, this is what the draft 07 talks about. It has metric flags, and 3 bits are defined. D for discontinuous, or you could have bit n. If it is set, then it says the metric has been normalized because you don't carry the intent that was propagated by the sender in the local domain. So you need to normalize the local cost to map with the intent that is sent from the sender. And the way we will determine the discontinuity is all the BGP routers that modify the next hop, they must be supporting these new extensions. Only then the receiver, the ingress will know that metric flags have been updated, and they can make a decision. Right. So now we are going to let, and this is where I can look for input once I'm done with the presentation, that do we need the entire incomplete metric values be propagated to the ingress? And I've collected some feedback from operators offline, where some people may say that it's good to have, because we can use it for either the policy that I have, or by putting a low preference, or use a tiebreaker if I have multiple paths. So discarding them is easy. We could have discarded up front when the place where it was not supported, but it opens up opportunities to prefer the ingress with multiple options. Right. So next slide. Before we move to NHC, I'm going to just share this thought that if you go with the AIGP attribute option, these are thoughts that AIGP attribute has been deployed. Let's assume it's pervasive, right? And we will lead all routers that modify the next hop today. We will have to support, those routers have to support this generic metric TLV extensions. That means they need to update the metric flags if they don't understand the metric type, or if they do understand metric type, then they have to update the metric value. Right? So in case if a router does not support the router that is modifying the next hop, and that doesn't support generic metric extensions, what will happen, like we talked about before, it will propagate the AIGP attribute, and basically will not be able to identify whether it is a continuous path or a discontinued path. It's quite possible that dbit unset, we do not know whether it has been properly set or not. So it opens up for opportunities for ambiguity. Next slide. Now, this is the second option, where let us say we leverage the next hop capability attribute. Now, this is a work in progress, where we can provide a definition or a scoping information for a particular attribute. And NHC, like we know, is an optional transitive attribute. So it minimizes the router that needs to be upgraded to support this one. But let us say we only talk about the NHC capability, NHC attribute alone. We would need those routers that modify the next hop to support the NHC, because they need to propagate the new capability because they're modifying the next hop, number one. Number two, it would be prudent to upgrade all the ASBRs to support the NHC, so that they know it is going beyond the one administrative domain, and they can stop leaking this transitive attribute. Right? So based on the policy or based on the implementation, we can avoid if the ASBRs are upgraded. This is just for the NHC capability and then the attribute. Now, if we leverage the NHC attribute for generic metric, this is a proposal, and the draft has not been updated with this, but we will do it once the session is over, where we will have the new capability TBD for the NHC, and then the entire generic metric TLV can be propagated. What this means is all the routers that modify the next hop, which need to provide this generic metric TLV, have to support NHC and have to support this generic metric attribute. Right, so that's one. As we said, ASBR, they would have been upgraded anyway to support the NHC and to provide the to prevent the attribute leak. Now, the discontinuity determination is if a router modifies the next hop, but that does not support NHC for whatever reason, the gap can be found because the base NHC supports that. The next hop validation will fail, and that's one. And let us say we have all the routers support the next hop but then they need to also support the NHC capability, the geometric extensions in this. So therefore, they will set the D bit if they don't understand the numeric type. If they do, then the discontinuity determination is done, because you will get the NHC attribute with the generic metric TLV and will be able to find the discontinuity bit being set. And the ingress routers can then use them for, like before, based on the policy, either they can discard or put low preference or use them as a tiebreaker. Now, while we see all of this, we know for sure in the local domain, all the routers should behave similarly in the same manner because of the best practice decisions. It's only the question is what is the router that is modifying the next hop, and how is the control information being propagated. Right? Next slide. This is my last slide. Some deployment considerations. If you go with the NHC attribute option, we could say let the current deployment of AGP let it be the way it is. In which case it carries default IGP costs, and for those vendors and implementations who carry non-IGP default, we can get them corrected and say any non-IGP default cost have to be propagated to the new option here. That way we can keep the two things separate. And NHC attribute is introduced to the network anyway, given the multiple use cases. We have already existing capability that we need to propagate, right? So we have that, and let's leverage. And given that IDR is focusing on making this attribute scoping is an important thing, we could leverage that NHC deployment in the network. And what in this particular case, generic metric extensions requirements are those routers that modify the next hop, they have to support the extensions as per the generic metric TLV. And like before, they have to either update the metric flags that they don't understand and therefore it is discontinuous, or they update the metric value because they do understand either locally, in which case it's an accumulation, or they translate, in which case it is still an increment with a non-zero value, right? Now, this means that the generic metric TLV carried in the NHC in all routers that modify the next hop. So all metric types down the line in the generic metric TLV should be updated. So we don't just look at the latest or the first one that we're getting introduced in the generic metric TLV. The expectation is the procedure of the router that is supporting the generic metric extensions it has to iterate through all the metric types that is being sent by the sender, by the originator of the route, and update the metric values or the flags accordingly. Because we've seen some requirements where a path can be described as with multiple intents, not just let's say bandwidth or latency. It could be combination of multiple intents, and therefore ingress router can decide the multiple intents for their choice of selecting the paths. Right. This is the last slide. I'll pause here for any questions, and the next slide should be the last. So just check. Yeah, exactly. This is the last slide. Please, any questions?
Jeffrey, go ahead. Did you have a comment?
I did have a comment. So the way I've sort of been interpreting this bit of work is that Next-Hop capabilities solve most of the scoping headaches that we were trying to work through. And if we tried to actually solve this in AIGP, we probably have to do some level of correction in AIGP that's similar to what's already there. So in terms of does it go in one versus the other, Next-Hop capability is nicer because it already fits. AIGP is where it was originally intended for, but we don't have to keep using it if it's not a great fit. The thing I do want to sort of highlight for the working group that you clearly are trying to articulate very well is that even though the feature, Next-Hop capabilities is able to enforce the scoping in a very nice fashion, the headache that isn't really solved by this completely is that you have to have a contiguous domain of deployment for a set of these metrics that you're looking to make use of. And the challenge in some of these circumstances isn't so much is the scoping working or not, it's does a given domain, like say an IBGP mesh, all have consistent access to the same metrics? And if not, what do you do about that in terms of things like route selection?
Right. So Jeff, the assumption here is within a domain, if the domain operator has chosen a particular metric type, then it has to be consistent across all the routers in the domain. Otherwise, we'll end up in a loop, in the traffic loop, right?
Exactly.
So while we are talking about the control plane, signaling propagation here, the ability of a router to choose multiple metric types, what to normalize and what to choose, has to be consistent across all the routers. With tunnel networks, maybe we can get away with it, but it's quite possible that we will have a combination of best path, best effort forwarding as well as tunnel. So we don't want to get into those complications, what I feel.
Exactly. And I think you were trying to make this point clearly in the presentation, and this is a generic thing, not specific to your presentation. We have to have consistency for these types of things that can bias route selection, and this feature can't provide the entirety of the thing. That's what I'm trying to highlight.
Thanks, Jeff.
Any other comments? Kaliraj, brief, we're running a little late.
Yeah, I was
Go
just
ahead.
trying to ask if any thoughts about the NHC AIGP version of the attribute, whether it interoperates with the old AIGP, backward compatibility with.
Backward compatibility with the existing AIGP, is that what you mean?
Yeah, transition.
Actually, one, we don't have to avoid interoperability here. Basically, one path can get AIGP and then other path can get NHC, but carrying the AIGP TLV, AIGP metric value. So they are comparable because they both have been accumulated over a path. So we can compare the two paths. We can have that clarified in the draft once I update this.
Okay.
We'll need to close this off, Srihari. And Kaliraj, would you send your last comment to the list? Kair, did you have something you wanted to
Yeah,
say?
just a quick question for Shriyari. Shriyari, if the last point you made holds true only if it has the same metric types across both the different attributes, correct?
That is correct, because I'm assuming AIGP today is going to be used only for default IGP cost. And if they're different, then we're going to get into comparing apples and oranges, right? So.
Okay, thanks.
Thanks. We're going to go on to the next presentation. Thanks, Srihari.
Thank you.
And if you would, and Kaliraj would send your point to the list. I don't think I've seen that on the list. Thank you. We're going to now go, just a minute. Our next go ahead, Yao. I will
Okay.
run slides for you.
Okay, thank you. Hello, everyone. This presentation is about advertising set algorithm information in IGP. And it is not a new draft, so this presentation will be short. Next, please. And currently, as in RDR BGP SR segment seg type CXT, when delivering SR policy via BGP, SR algorithm can be optionally specified in all segment sub-tier Vs besides those defined for SIMPRS adjacency sets. And there's a working group draft in LSR. LSR claims that the algorithm can also be included as part of an adjacent set advertisement for SIMPRS in IGP. So this document, based on the above draft, this document defines new segment types to provide optional algorithm for SIMPRS adjacency sets when delivering SR policy via BGP. And although we get some support, but it didn't pass the working group adoption last September because there's not enough interest in the list. So next slide, please. And here are the main updates since last working group adoption call. First, Jian from Verizon has joined as a co-author, and based on Zheng Chang's comments, the segment type L and the related subtier V have been modified to cover the IPv4 non-point-to-point unnumbered adjacency case and to keep aligned with those defined for IPv6 links. And based on Nat's comments, the references to other documents have been corrected. And I would like to thank Katen, Nat, Zhenqian, and Jim for their comments and suggestions since the draft was proposed. And next, please. And from this slide, we can easily see what has been updated for segment type L. So now the local interface ID and remote node address information has been added. So, and it is aligned with TLVs defined for the IPv6 adjacencies. Next, please. And the authors request for more interest, reviews, and comments on this draft, and we would like to request for the second working group adoption call in the near future. And that's all.
Any questions on this? Any comments? Okay, I will send some questions on the list due to time, but I will also add this as a second adoption call. We'll go on. Thank you very much, Yao, for your brief presentation. You've brought us back on time. Let me put our last presentation which is to be presented by Ka. Ka, do you see the presentation?
Yes, hello, can you hear me?
I can certainly hear you. You're loud and clear. Thank you.
Okay. Hello everyone, this is Ka, and my topic is about BGP as a policy extension for template. Next slide, please. As we know, BGP can use to propagate the SR policy candidate path to the head-end nodes in the network. And the basic attributes of candidate paths are defined in this protocol. Next slide, please. But in application, the head-end routers may need to define many features of the candidate path. Some features are only meaningful to controller and head-end nodes. BGP protocol no need to know them. Use template can share the information that BGP need to know. Features may change frequently, and the template can be used to avoid BGP protocol changes too frequently. And also, different SR policies with the same feature can use the same template, then can simplify configuration and improve maintainability. We can look this example. There are two SR policy. SR policy 1 has the endpoint is 1.1.1 and the color is 100. The SR policy had a candidate path with preference 100, and this candidate path need a backup path and also need a seamless BFD enable and have BFD parameters and also need traffic statistics. And another path in SR policy 2, also in SR policy 1 has a candidate path with preference 200, and the parameters are different from the primary path. Thus, we can define two different templates for primary path and backup path either. So this can simplify the configuration. Next slide, please. So we use the template defined as this. It is a group of features for SR policy candidate paths, and we can use an identifier which is meaningful to the head-end nodes of SR policy. And the identifier is configured by user or controller and is only valid on the head node locally. And template process is as follows. First, we need to configure a template with template ID and template contents on the head end of SR policy. Look at the template 1 and template 2. The template 1 is for primary path and template 2 is for the backup path. These two paths has different parameters. And then the PCE calculate path of SR policy and update the path information using BGP update message, which carries the template ID in SR policy candidate path attributes. And then SR policy head node ends find the contents of the template using template ID and then can set up paths with the features defined in the template. Next slide, please. And so we define TLV for template that is template ID sub TLV, and it is used in the SR policy in the BGP update message and as an attribute of the candidate path. And the sub TLV has the template ID and also the flags, which is to be defined in the future. Next slide, please. This is the operation considerations for the template. First, advertisement of SR policies. When BGP advertise an SR policy, different candidate paths of the same SR policy may have different template IDs, or the same template ID, depending on the attributes required by the candidate path of the SR policy. And when the head end received the SR policy, the SR policy template is only to be processed on the head end of SR policy and is being incorporated in an SR policy module. The SRPM finds the local configured template by template ID and get all the attributes that is configured in the template and then process the candidate path with these attributes. For example, if the template configure seamless BFD, then the SRPM can create SBFD sessions for each segment list in the candidate path. If there is no template found, the SRPM should ignore the template ID and use the candidate path as there is no template ID. Next slide, please. And
just a minute, Keaton, did you need to, can you wait till the end of the presentation for your question?
Okay. Yes, I can wait.
Okay, please go ahead, Ka.
Okay. And this is not this draft has been presented twice, and this is the third time. And there is some changes before after the last presentation, and we add the template name in the template subtitle, and it is optional. And it can be used to add description of the template. Next slide, please. And welcome questions and comments. And can I ask the WG adoption?
Go ahead, Ketan. It's your turn.
Ketan Talaulikar, Cisco. Is the template the same as the profile ID in PSEP?
You mean profile ID?
In PSEP, we have something called profile ID in PSEP. Is that the same thing as this template?
Yes, I think it maybe it do the same thing as profile ID.
Okay.
It
In
can do
that case, I think it might help to call it a profile ID perhaps, and also put a reference, just an informational reference to the PSEP work that's already there. Just a suggestion. Yeah.
Oh, okay. We can talk it later and can define it better.
Ketan and Ka, I'd like you to put that question and Kate and Ka's response on the list.
Okay, okay. No problem.
Other questions? Kaliraj, go ahead.
So yeah, I mean, just generic BGP questions. Is this template ID carried in the NLRI or attribute? And who manages this allocation? What is the scope of uniqueness of this template ID?
I think the template ID can be allocated on the head end of the SR policy, and it is only valid in the head end of SR policy, and not maybe different devices can use the same template ID. So I think the head end or the controller can allocate it.
Okay, from the presentation, I thought the head end is who receives it, not allocates it. And does the mechanism work with RRs as well?
Sorry, I.
So basically, I'm just thinking if you have a scope of the template ID, which is global, that may not work because you need to have it on a per advertiser basis. And if you have it on a per advertiser basis, then the receiver need to maintain the template ID on a per advertiser. But two different advertisers will need to coordinate on their allocation, and it should not collide at the RR with path hiding. So those are just the things that came to mind, and I just want to say, and please take care of that. So maybe you already considered it. I have not read the draft or paid attention to it. Just voicing out the opinions.
Okay. Thank you very much. I'll consider it.
Kaliraj, I would like you to put that question on the list. And Ka, we have a requirement for ITF of some discussion on the list prior to ITF 119. So if you would respond to Kaliraj on list, both respond about the PSAP and about Kaliraj's questions. Will
Okay,
you
okay.
do that for me?
Yeah,
Thank
yes.
you.
Thank you very much.
Appreciate that. Okay, folks, we've come to the end of our time. Is there any final comments before we close? Otherwise, we thank you. I've asked several people to put things on the list. The reason is if you want a presentation at ITF, we need to have some discussion on the list. So I think we had a couple natural points. At that point, any comments, Jeff, before we close?
None for me, thanks.
And I think we've lost Kair, so I wish you a good day, and we shall hopefully see you virtually or online at ITF. Bye-bye.